Students, good morning to all of you. Students in class 12 physics in unit 6 optics. Our today's topic is refraction through spherical surfaces. Okay. Now we have two kinds of spherical surfaces. One is convex spherical surfaces and second is concave spherical surfaces. This. This is a convex spherical surface and this is a concave spherical surface. Here students, these surfaces divide the medium into two parts. After the mirror or after the spherical surface, the medium is denser and before is lighter. Okay, this is denser medium and this is lighter. Similarly here, after the concave spherical surface, this is denser medium and this is rarer medium. Okay, now we are relate the center of curvature of the spherical surface with the refractive index of the 2 medium. Okay, now for relating it, for first case, convex spherical surface. Convex spherical surface. Okay. Suppose we have a convex spherical surface. Okay. M. Okay. Now the point at the center of M dash is called core of the surface. Okay. Now this is center of the sphere whose part of this spherical mirror and the line which is passing from center of curvature to the whole either side of the sphere is called principal axis. Clear? This is principal axis of the spherical surface. Now, let's say we have a point object which is located on the principal axis at O and the two rays traveling from O. One is normal to the spherical surface which is goes undeviatedly in the straight line with the principal axis toward OCX. Okay. Now the second ray which is traveling with an angle and falls on the spherical surface by making an angle with its normal or the line center of curvature because it traveling from rarer medium to denser medium, it bends towards normal and traveling in the direction of I. Let's see, this point is A. Okay. Now this is the image of object O at I. Now we find here when we drop an perpendicular from A to the principal axis, let's say it meets principal axis at M. Now here we use some angles. Okay. Now this is angle of incidence I and this is angle of refraction R with the 1 minute. This is normal. So this is angle of refraction R. It is clear or not? Now let's say the incident ray makes an angle of alpha with the principal axis. Image forms an angle of beta with the principal axis, and normal forms an angle of gamma with the principal axis. Now, by using the two triangles, let's say this is triangle 1, this is angle of incidence, and light is traveling towards I. Okay, so see, OCA. Okay, this angle is alpha and this angle is gamma. Now you will calculate by exterior angle property of triangle that exterior angle is sum of opposite to interior angle, value of angle I. So angle I is equal to alpha plus gamma. It is clear? And here second thing, by using triangle O, A and 1. This is R and this. Okay. Now this is this. Okay. Now this angle is R, this angle is beta, and this angle is gamma. It is clear? In triangle CIA. Clear? By using this triangle you can calculate gamma is equal to R plus beta. Clear? Therefore you will calculate from here the value of angle R is equal to gamma minus beta. These are the two incidence and refracted angle by using the two figures of this. Now, the light is traveling from rarer medium to the denser medium, and the image of object O is formed at point I according to Snell's law. According to Snell's law, that sin I, ratio of angle of incidence, I to ratio of angle of refraction is equal to refractive index of second medium with respect to first medium. This you can write as mu2 upon mu1. Okay. Now, if the spherical surface is very small, if spherical surface is very small, then sin I is equal to I and sin R is equal to only R for the small angles. Okay, therefore I upon R is equal to mu2 mu1. Clear? Now by using cross multiply we get mu1 into I equal to mu2 into R. On putting these value of I and R here, we get mu1 I we have alpha plus gamma and mu2 R is gamma minus beta. Okay, now multiply inside and find the value of gamma in one side and alpha in other side. Calculate it. So we get from here mu1 alpha plus mu2 gamma and mu2 gamma minus mu1 mu2 beta. Okay, now this mu2 is substitute to here, then we get mu1 as common, alpha plus beta is equal to gamma is common, and we get mu2 minus mu1. It is clear or not? Now from these figures we will calculate the value of alpha, beta and gamma. See, this will raise. Now the distance of object to the pole is u, the distance of image from the pole to the point is v, and the distance of pole to the center of curvature is r. It is clear? Now here one thing is understood, that if the aperture of the spherical surface is small, then for a small surface, a small spherical surface, P and N are coincide. That is OP equal to ON equal to minus U by using the convection of sign. Now PI equal to NI equal to V is positive, and second PC equal to PN equal to capital. Now see, in triangle OAN for small angles, tan alpha is equal to alpha, and you know the value of alpha is perpendicular upon base. So you will get from here AN upon OP or OM. Clear? Second, tan beta in triangle IAN tan beta is equal to beta, and this we get AN upon NI. Okay, and this we write AN upon OP, this is AN upon PI as per convection sign, and in triangle CAN tan gamma is equal to gamma is AN upon NC, which is AN upon PC. It is clear? By putting all these values in equation first. Let's say it is equation first. Now mu1 is equal to alpha. Alpha we have AN upon OP and plus AN upon PI is equal to gamma we have an upon PC and mu2 minus mu1. It is clear? Now an is common. An is common from the numerator from the left side, so we get mu1 an and also put the values of OP, PI and PC. We get 1 upon OP we have minus u plus 1 upon PI we have V is equal to an upon R mu2 minus mu1. Clear? Now this an is cancelled by each other, then we get this mu1 1 upon V minus 1 upon U is equal to, take mu1 as common from here, we get mu1 mu2 upon mu1 minus 1 into 1 upon R. Clear or not? Now this mu1 is cancelled and we get the final result. Yes. Okay, yes, it is correct. When we substitute beta towards left and mu2 gamma towards left, so mu1 gamma towards left, then we get the result is mu1 alpha plus mu2 beta. So we have here beta mu2. Okay, and this is mu1 is known as common. This is mu1. So we have mu1 upon mu2 and here is okay. Now this is mu1 and this is 1 minute. From this line we get mu2 upon V and minus mu1 upon U. Now is okay? This. Okay. This is mu as common, or without taking common, we get mu2 minus mu1 upon R, and this is the required relation. Yes, this is the required relation for the spherical convex surface. Note down it. This is the relation between refractive index and refractive index and radius of curvature for convex spherical surface, convex spherical surface from vector medium to density. Okay. Next, lens maker's formula. Okay, next we have lens maker's formula for thin lens. Here the situation is formed. Let we have a thin lens which divides medium. mu1 is rarer medium, inside the lens is medium is denser, let's say of the refractive index mu2, and when it emerges out, then it is again in the air or with the rarer medium. Okay, now let an object is placed on the principal axis of the lens. The two lights which is traveling from the object, one is normal to the lens, goes undeviated towards eye, and second light which is incident with an angle of incidence eye with the normal is refracted by the first refracting surface and moves in the direction from A to B. Okay, and then again suffer refraction from second refracting surface in the direction of B to I. Okay, now if this second surface absent in the after the first reflection, then we get the image formed by the object by first refracting surface is at I dash, because by suffer refraction OA initially goes in the direction of I dash. So we can say the image formed by the first refracting surface at I dash. Okay, and this image formed by the first refracting surface is behave like a object for the second refracting surface, and when the light is traveling from or suffer refraction at point B, it will move in the direction of I. Okay, then the actual image formed by the thin mirror of object O at I. Therefore, we can use here some distances like O to optical center is U, distance of object. The initial image formed with distance O to I dash is V dash, and the final image formed by the mirror at I, which is at a distance V. Okay, now by relation of spherical refracting surface, spherical refracting surface at A we have mu2 and the distance of image is B dash minus mu1 and distance of object is U is equal to mu2 minus mu1 upon R. Here this is particular. Now at reflection at B, refraction at B, again from the same formula, the light is traveling from this medium. 1 minute. The light is traveling from A to B from the second medium. Okay, this we have mu1 upon V and plus mu 2 upon v dash. When the light is traveling from here, this is first medium, and then it appears here. Okay, this is negative. Okay. And is equal to, we get mu 1 minus mu 2 upon r, because the object and image at the same side. ठीक है, by taking common we get minus mu 2 minus mu 1 upon r. Clear? Or we say for this is R1 and for this is R2, because the refractive index of the two different spherical surface should be different. Therefore, this is your equation second. Now, by adding equation first and second, by adding equation 1 and 2, what we get? Plus v2 minus v1 and minus v2 plus v2 upon v1 and minus v2 upon v1. Yes, cancel, and we get mu 1 upon v minus mu 1 upon u is equal to mu 2 minus mu 1 is common, and we get 1 upon r1 minus 1 upon r2. It is clear? Now, mu is common. Mu 1 is common. We get 1 upon v minus 1 upon u is equal to mu 1 is also common from here. We get mu 2 upon mu 1 minus 1, and this we have 1 upon r1 minus 1 upon r2. Now this mu 1 is cancelled, and we know that, or we say by Lenz's formula, one upon v minus 1 upon u is equal to 1 upon f. Okay, this is your equation second. By using value of 1 upon v minus 1 upon u is f, we get 1 upon f is equal to mu 2 1 minus 1 upon r1 minus 1 upon r2. This is the required Lenz's method formula, and this is the relation between focal length, refractive index, and the radius of curvature of two spherical surfaces, which is used to making the lens. This is required Lenz's Nichols formula.